The scenario involves a 200 amps 480 volts 3-phase service with a 200 amps fuse disconnect. A feeder consisting of 3/0 THHN is run approximately 180 feet or 200 amps non-fused disconnect. From there, a multi-wire device is installed, with number 6 THHN conductors leading to 60 amps fuse disconnect and number 2 THHN conductors leading to 100 amps fuse disconnect. Both the 60 amps and 100 amps disconnects are for concrete mixer motors. The installation was intended to comply with tap rules outlined in Article 240.21b and 430.28 and 2 of the National Electrical Code, but the inspector disapproved the installation due to overfusing of the tap conductors. The inspector's reasoning is that the tap conductors, which are number 6 THHN and number 2 THHN, are rated for 60 amps and 100 amps respectively. The upstream fuse disconnect is rated for 200 amps. According to Article 240.21b, the overcurrent protection for a tap conductor must not exceed the ampacity of the tap conductor. The original reasoning was based on Article 430.28 and 2, which allows for taps to be taken from the line side of a motor circuit protective device under specific conditions. These conditions include, firstly, taps must not be longer than 25 feet, and secondly, the ampacity of the tap conductor must not be less than 1/3 the ampacity of the circuit conductor that it taps. In this case, the 3/0 THHN. The inspector's reasoning is correct based on Article 240.21b. The tap conductors number 6 THHN and number 2 THHN are not rated to carry the full 200 amps current from the upstream fuse disconnect. The resolution involves two possible options. Firstly, replace the tap conductors with conductors rated for at least 200 amps, for example 4/0 THHN. Secondly, reduce the rating of the upstream fuse disconnect to match the ampacity of the tap conductors, for example, install a 100 amps fuse. Once the overcurrent protection for the tap conductors is appropriately addressed, the inspector should approve the installation. Article 240.21b specifically addresses tap conductors in overcurrent protection. This section outlines the conditions under which tap conductors are permitted without overcurrent protection at the tap point. It's crucial to understand these rules to ensure electrical safety in compliance with the National Electrical Code. The general rule is that tap conductors must be protected at their ampacity. However, certain exceptions allow for tap conductors to be used without overcurrent protection at the point where they tap from the larger feeder. These exceptions are subject to specific requirements regarding the length of the tap, the ampacity of the tap conductors relative to the feeder conductors, and the location of the overcurrent protection. One common application of tap rules is in industrial settings where multiple loads are supplied from a single feeder. Tap conductors can be used to distribute power to individual loads, provided that the tap conductors meet the requirements of Article 240.21b. These requirements are designed to prevent overcurrent conditions on the tap conductors, which could lead to overheating, insulation damage, and potential fire hazards. In the described scenario, the tap conductors, number 6 THHN and number 2 THHN, do not meet the requirements of Article 240.21b because their ampacities are less than the rating of the upstream overcurrent protection device, which is the 200 amps fuse disconnect. This means that if a fault occurs on the tap conductors, the 200 amps fuse may not trip quickly enough to protect the tap conductors from damage. The National Electrical Code defines ampacity as the maximum current in amps that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. The ampacity of a conductor depends on several factors, including the conductor material, size, insulation type, and the ambient temperature. THHN is a common type of insulation used for electrical conductors. It is rated for a maximum operating temperature of 90 degrees Celsius in dry locations. The ampacity of THHN conductors is listed in National Electrical Code Table 310.16. For example, a number 6 THHN copper conductor has an ampacity of 55 amps when installed in a raceway or cable. A number 2 THHN copper conductor has an ampacity of 95 amps under the same conditions. These ampacities are based on the assumption that the conductors are installed in accordance with the National Electrical Code requirements, including proper spacing and ventilation. Article 430.28 specifically addresses motor circuit taps. This section provides rules for tapping conductors from a motor feeder or branch circuit. The tap rules for motor circuits are similar to the general tap rules in Article 240.21b, but there are some important differences. One key difference is that Article 430.28 allows for longer tap lengths in certain situations. For example, a tap conductor up to 25 feet long is permitted if the ampacity of the tap conductor is not less than one-third the ampacity of the feeder conductor and the tap conductor terminates in a single motor controller or disconnecting means. However, the tap conductor must still be protected from overcurrent at its ampacity. In the described scenario, the tap conductors are used to supply power to concrete mixer motors. This means that Article 430.28 applies. The original reasoning was that the tap conductors met the requirements of Article 430.28 and 2. However, the inspector determined that the tap conductors were overfused, which means that the overcurrent protection was not properly sized to protect the tap conductors. To resolve the issue, the tap conductors must be protected at their ampacity. This can be achieved by either replacing the tap conductors with larger conductors that have a higher ampacity or by reducing the size of the overcurrent protection device. If the tap conductors are replaced with larger conductors, the new conductors must be sized to carry the full load current of the motors, plus any additional loads that are connected to the tap conductors. The new conductors must also be protected from overcurrent at their ampacity. If the size of the overcurrent protection device is reduced, the new overcurrent protection device must be sized to protect the tap conductors from overcurrent, but it must not be so small that it causes nuisance tripping. The size of the overcurrent protection device must be carefully coordinated with the ampacity of the tap conductors and the starting current of the motors. In addition to the tap rules, there are other National Electrical Code requirements that must be followed when installing motor circuits. These requirements include proper grounding, bonding, and disconnecting means. Motor circuits must be grounded in accordance with Article 250 of the National Electrical Code. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. Motor circuits must also be bonded in accordance with Article 250 of the National Electrical Code. Bonding connects all of the metal parts of the electrical system together, which helps to prevent voltage differences from developing between them. A disconnecting means must be provided for each motor circuit. The disconnecting means must be readily accessible and must be able to disconnect the motor from all sources of power. The disconnecting means is typically a circuit breaker or a fused disconnect switch. When installing electrical systems, it is important to follow all applicable codes and standards. The National Electrical Code is the most widely used electrical code in the United States. It is updated every 3 years to reflect changes in technology and safety practices. The National Electrical Code is not a law, but it is often adopted by state and local governments as part of their building codes. Electrical inspections are typically performed by local building inspectors. The inspectors check to ensure that electrical installations are in compliance with the National Electrical Code and other applicable codes and standards. Electrical inspections help to ensure the safety of electrical systems and prevent electrical hazards. In the described scenario, the electrical inspector disapproved the installation because the tap conductors were overfused. This is a common violation of the National Electrical Code. By understanding the tap rules and other National Electrical Code requirements, electricians can avoid this and other common violations. This ensures the safety and compliance of electrical installations. The correction involves ensuring that the overcurrent protection for the tap conductors does not exceed the ampacity of those conductors, complying with NEC Article 240.21b. This can be achieved by either increasing the size of the tap conductors to match or exceed the existing overcurrent protection, or reducing the size of the overcurrent protection to match the ampacity of the existing tap conductors. In the given scenario, the 3/0 THHN feeder has a certain ampacity, which can be found in NEC table 310.16 depending on the insulation type and installation conditions. The tap conductors, number 6 THHN and number 2 THHN, also have specific ampacities listed in the same table. The overcurrent protection device, in this case the 200 amps fuse disconnect, must be sized appropriately to protect the tap conductors. If the tap conductor's ampacity is less than the rating of the overcurrent protection device, the overcurrent protection device must be reduced in size to match the tap conductor's ampacity. Alternatively, the tap conductors can be upgraded to a size that has an ampacity equal to or greater than the existing overcurrent protection. The tap rule in NEC 240.21b allows for specific exceptions to the general rule that overcurrent protection must be provided at the point where a conductor receives its supply. These exceptions permit tap conductors to be connected to a feeder or branch circuit without overcurrent protection at the tap point, provided certain conditions are met. These conditions typically involve limiting the length of the tap conductor, ensuring the tap conductor's ampacity is sufficient for the load it serves, and providing overcurrent protection at the termination point of the tap conductor. Article 430.28 allows for taps from motor circuits under specific conditions. Firstly, the tap conductors must not be longer than 25 feet. Secondly, the ampacity of the tap conductor must be at least 1/3 of the ampacity of the feeder conductors. Thirdly, the tap conductors must terminate in a circuit breaker or fuses rated no more than the ampacity of the tap conductors. Fourthly, the tap conductors must be suitably protected from physical damage. The exception in 430.28 is designed to allow for flexibility in motor circuit design while ensuring safety. However, it's important to carefully consider all of the requirements before applying this exception. The scenario describes an electrical installation with a 200 amps 480 volts three-phase service. This type of service is commonly used in commercial and industrial buildings to supply power to large equipment and machinery. The service consists of a service entrance, a main disconnect, and a distribution panel. The service entrance is the point where the electrical service enters the building. The main disconnect is a switch or circuit breaker that can be used to disconnect the entire electrical service. The distribution panel is a panel that contains circuit breakers or fuses that protect the individual circuits in the building. The feeder conductors run from the service entrance to the distribution panel. The feeder conductors must be sized to carry the total load of the building. The branch circuits run from the distribution panel to the individual loads in the building. The branch circuits must be sized to carry the load of the individual loads. The National Electrical Code provides detailed requirements for the installation of electrical services, feeders, and branch circuits. These requirements are designed to ensure the safety of electrical systems and prevent electrical hazards. The scenario also describes the use of THHN conductors. THHN is a type of insulation commonly used for electrical conductors. THHN stands for thermoplastic high heat resistant nylon. THHN insulation is resistant to heat, moisture, and oil. THHN conductors are typically used in dry locations. The National Electrical Code specifies the ampacity of THHN conductors. The ampacity of a conductor is the maximum current that the conductor can carry continuously without exceeding its temperature rating. The ampacity of a THHN conductor depends on the size of the conductor and the ambient temperature. The scenario also describes the use of fuse disconnects. A fuse disconnect is a switch that is used to disconnect a circuit from its source of power. The fuse disconnect contains fuses that protect the circuit from overcurrent. Fuse disconnects are commonly used in motor circuits and other circuits that require overcurrent protection. The National Electrical Code requires that fuse disconnects be installed in readily accessible locations. The fuse disconnect must be rated for the voltage and current of the circuit it is protecting.